The impact of greenhouse gas emissions on our planet has been a subject of much discussion in recent years. While cars are considered to be a major contributor to this problem, there is also a lot of misinformation and confusion surrounding this topic, making it challenging to differentiate between facts and myths. The graph shows the perspective to compare the emissions. Continue watching to see where the numbers come from. Let's start with electric cars. Greenhouse gas emissions associated with electric vehicles are produced during two stages: battery production and power generation. Lithium battery production requires three minerals: lithium, cobalt, and nickel. The largest lithium producers are Australia, Chile, China, and Argentina, while the Democratic Republic of Congo is the largest cobalt producer. To achieve net zero by 2050, an estimated 2 billion EVs will be needed, requiring approximately 18 million tons of lithium and a similar amount of cobalt, in addition to the 2 million tons required by other industries. Worldwide reserves of lithium currently stand at around 36 million tons, including new discoveries in Iran and India, which are enough to meet demand. However, according to recent estimates by the U.S. Geological Survey, the total world reserves of cobalt stand at around 8.3 million tons, which is less than half the amount required by 2050. This raises concerns about potential shortages due to the concentration of production in the Democratic Republic of Congo and issues with mining practices in the region. Therefore, despite lithium-ion batteries being 95% recyclable, the development of new EV battery technology is necessary to reduce dependence on cobalt and avoid potential shortages. Recycling efforts are expected to make most EV batteries recyclable within a few years. There are a number of companies around the world receiving funding from government agencies as well as the private sector to scale up rapidly the capacity to catch up the piling up spent batteries. Recyclers are now working closely with automakers to guide their battery production into a more recyclable form, which will lead to much faster and more efficient recycling. This is dismantling the argument that the batteries will end up in landfills. Now let's look at the emissions associated with electric vehicles. First, the battery. U.S. Department of Energy and the European Commission Joint Research Center estimate that an average 60 kilowatt-hour lithium-ion battery production can generate 10 to 17 tons of carbon dioxide emissions due to energy-intensive steps such as raw material extraction and processing, battery cell and nodule manufacturing, transportation, and waste. In the future, these emissions will be reduced through recycling efforts. Now let's look at emissions from power generation. The amount of carbon dioxide produced per kilowatt-hour of electricity generated in the United States can vary depending on the specific mix of energy sources used to generate electricity in a given region. However, according to the U.S. Environmental Protection Agency (EPA), the national average emission rate for carbon dioxide from electricity generation in the United States in 2022 was 0.379 kilograms of carbon dioxide per kilowatt-hour of electricity generated. Based on actual numbers, electric cars generate approximately 17 kilograms of carbon dioxide per 100 miles traveled. Now, let's examine and evaluate fuel cell hydrogen cars. Hydrogen fuel cell cars are becoming more popular as an alternative to traditional gasoline-powered cars. These cars use hydrogen and oxygen to generate electricity, which powers the vehicle. In essence, hydrogen cars are electric cars that use a fuel cell instead of a battery. They are zero-emission vehicles, very quiet, and have higher energy efficiency than gasoline-powered cars. However, infrastructure and cost issues have hindered their widespread adoption as they require a reliable supply of hydrogen fuel, which is not widely available, and the cars themselves are still expensive. Despite these challenges, governments are investing in research and development of hydrogen fuel cell technology, and the number of hydrogen refueling stations is increasing, improving the viability of these cars. Moreover, the efficiency of hydrogen fuel cells is expected to increase in the future, which could make them even more cost-effective. How is hydrogen produced for fuel cell hydrogen cars? Various methods can be used to produce hydrogen, with the most common method being steam methane reforming, which accounts for over 90% of the world's hydrogen production. Steam methane reforming process is around 75% efficient, with most of the energy lost as heat. The cost of production depends on several factors, including the facility's location, natural gas availability, reforming technology, and facility size, which can cost up to $7 per kilogram of hydrogen. The steam methane reforming process produces 9 to 12 kilograms of carbon dioxide for every 1 kilogram hydrogen produced, which is a significant amount. Therefore, research and development efforts are underway to develop new processes that can capture and store the carbon dioxide produced during hydrogen production and to develop alternative methods that are more environmentally friendly. Another way of producing hydrogen is through electrolysis, which is more efficient than steam methane reforming and does not produce any carbon dioxide or carbon monoxide, although it only accounts for about 4% of hydrogen produced. The same method is used with renewable energy, but it accounts for only 1% of the total hydrogen production. The tank size of a hydrogen fuel cell car can vary depending on the make and model of the vehicle, with an average tank size of around 5 to 6 kilograms of hydrogen. Since 1 kilogram of hydrogen contains around 33 kilowatt-hours of energy and is approximately 60% efficient, a hydrogen fuel cell car with a 6 kilograms tank could potentially provide a range of up to 350 miles. Based on actual numbers, fuel cell hydrogen cars generate approximately 19.5 kilograms of carbon dioxide per 100 miles traveled. Gas-powered cars have long been regarded as symbols of freedom and adventure by car enthusiasts. The sound of the engine roaring, the smell of gasoline, and the feeling of shifting gears all contribute to a unique experience that is difficult to replicate with an electric car. Many of us have grown up with a fascination for gas-powered cars since childhood, as they offer a sensory experience that electric cars simply cannot match. To gain a better perspective, let's examine the emissions of gas-powered cars. The amount of carbon dioxide generated during gasoline production can vary depending on several factors, such as the production techniques used, the origin of the crude oil used to make the gasoline, and the energy sources utilized in the refining process. On average, it is estimated that the production of 1 liter of gasoline can emit approximately 2.5 kilograms of carbon dioxide. The gasoline production process involves several steps, including crude oil extraction, transportation, refining, and distribution, each of which has the potential to generate greenhouse gas emissions. For example, significant amounts of energy may be required for crude oil extraction and transportation, and refining necessitates energy-intensive processes such as heating and distillation. Additionally, gasoline is a non-renewable resource, and its extraction and use can contribute to environmental issues such as oil spills and habitat destruction. The amount of carbon dioxide emitted by a gasoline-fueled vehicle can vary depending on factors such as the car's make and model, driving conditions, and fuel efficiency. However, on average, a typical gasoline-powered car emits around 2.3 kilograms of carbon dioxide for every liter of gasoline burned. This figure is calculated based on the amount of carbon in the gasoline and the amount of carbon dioxide produced when the gas is burned in an internal combustion engine. It's important to note that carbon dioxide emissions from gasoline-powered vehicles are only one aspect of their overall environmental impact. The combustion process also generates other pollutants such as nitrogen oxide, carbon monoxide, VOCs, and particulate matter. Based on actual numbers, gas-powered cars generate approximately 64 kilograms of carbon dioxide per 100 miles traveled. And here are two graphs that can give perspective on emissions and operating costs of all three cars. The graph data indicates that electric cars and fuel cell hydrogen cars have similar emissions in the US. However, in countries such as Canada, France, and the European Union, where a greater portion of energy production comes from nuclear and renewable sources, electric cars are significantly more environmentally friendly. Furthermore, fuel cell hydrogen cars are more expensive to operate and face a significant challenge due to the lack of hydrogen refueling infrastructure. However, fuel cell hydrogen technology can be much better suited for commercial transportation given its shorter refueling times and the smaller number of refueling stations needed. Furthermore, there is a lot of room for improvement in fuel cell efficiency, which can reach up to 80%, and also utilizing sustainable methods of hydrogen production, which will bring fuel cell hydrogen cars closer to electric cars in terms of environmental friendliness. At this point, the big advantage of fuel cell hydrogen cars would be their refueling time. Also, electric cars are expected to improve significantly once fossil fuel energy production is eliminated and new battery technologies are implemented. Exciting news has recently emerged that a new power generation technology, nuclear fusion, has been successfully tested and is expected to be developed in about 10 years. This breakthrough has the potential to completely eliminate fossil fuel power generation, which would be a significant step in reducing emissions and improving the overall sustainability of the transportation sector. Despite our love for gasoline-powered cars, it's important to acknowledge that electric and hydrogen cars are the way of the future. While we may try to diminish the appeal of electric cars by pointing out their weaknesses, the reality is that gasoline cars belong to a bygone era. While classic cars will remain beloved for years to come, we must accept the reality and embrace new technology. Don't forget to hit subscribe, and thank you for watching.